Floor is yours, man.
All right, thanks, Navid. So I'll start with the service updates. And since I'm presenting Azure Media Services, let's look at the updates for media services. So
Malik,
in June 19th,
you want to spend 1 minute to introduce yourself, man?
so I'm Malik Soni. I'm a cloud solutions architect. I'm located in Irving, Texas office. I primarily focus on media customers for their media needs. And in this presentation, I'm going to show how big the media vertical is. Generally, when we speak about media, our views are very limited to maybe some movie studios and a couple other industries, but now it's spreading across all the industries. And then Azure Media Services has all the foundational building blocks which can help in every industry to meet their need for the large file challenges in current days. So with that, I'll switch back to the updates. So recently, Media Services has released the premium encoder, which supports 1080p and 30 frames per second. In Media Services, there are two encoders, the standard encoder and a premium encoder. With these updates, it enables organization to stream their live content at higher resolution, HD resolution, and 30 frames per second. Okay, go back to the presentation now. Let me present. Okay, and today we are going to talk about just the basics of media technology. It's a deep domain. Azure Media Services, and there are related services which complements media services span across different verticals. So I'm planning to have probably at least a couple more sessions progressively around media technologies. This one, just an introduction to the basic components of media services, followed by the demo. So media on Azure, you have heard AI on Azure, the database is on Azure, apps on Azure, but media on Azure has various reach. So first area is the media and entertainment uh, industry, where there are three distinct things happening. Is content creation is happening there, and Azure supports rendering and video editing tools. Content management includes the media asset management, archiving, machine learning on top of the media, correlation, as well as the metadata enrichment and search. Search is a big area for media in general. Search by the tag, search by the metadata. Sometimes it's curated metadata, sometimes it's automated metadata. And the third vertical is the content distribution and monetization, right? Any video which was created ultimately to reach to its viewers. That's where the Azure Media Services and component comes into the picture. And Azure can do live, linear, and on-demand over-the-top platform delivery for the media. Publishing workflows are supported. Audience analytics is done through the player, and personalization ad targeting is also done through the player, as well as the offer management. There is also another vertical in public safety. This is big for Microsoft in general as well. So there is a huge surveillance and intelligence data that's coming in, and media service is a cloud platform which provides processing of that high quality, high resolution files. So again, high scale ingest. The platform is all cloud based, so it can scale. Applied machine learning in the context of public safety, right? Maybe the face recognition or the object detection in a public area. Also added metadata enrichment and search on top of it. And there are a few other things for forensic IoT cameras, which can now directly connect or provide a stream to Azure Media Services. As well as there are a few use cases around smart cities and stadiums. These are all solutions that run on Azure utilizing media services. Now, everybody have seen Satya's monthly meetings on Streams, Microsoft first-party products, which is on Azure. So anytime you see video on Streams, it utilizes the media services backbone and the workflow and the components. Skype also utilizes, as well as the Yammer, Xbox, and MSN. So game streaming is also a big part of this media vertical. At the foundation here is media services is at the top level component, but underneath it utilizes storage account for media storage. There are certain cases where you can spin up the compute resources through media services, as well as you can leverage the network, the file transfer protocols, and cognitive ability provided by another top level solution called video indexer. And anytime you deal with media or the video files or audio files for distribution, you have to consider CDN. So it's also baked into the solution. Okay. So in this slide, it just shows the simple workflow. Let's say there is a soccer game going on and you need this game to stream and ultimately reach to the end of the users who are around the world, right? That's what your goal is. So in order for your game to be streamed and reach to the end audience, it has to go through these steps or the processes, and this is all inside Azure Media Services. So it starts with capturing the live ingest, or it could be the on-demand, but essentially a camera captures the event, send it to the cloud, then transcoding happens in the cloud, then media indexing also can be kicked off along the side. In terms of delivery, digital rights management encryption is a key piece here. So Google has Widevine, Apple has FairPlay, and Microsoft has PlayReady. So these are the encryption for specified for the stream. And also DRM determines whether user has permission to watch that video or not. So Azure Media Services has an abstraction of all the DRM services, which provided by Google and Apple and so forth, so that as the end user, I don't have to spin up additional servers for the DRM. Media Services can abstract that away, and it makes very easy as a producer to apply DRM on my stream. So once the DRM is applied, video on demand or live streaming is sent, the files are sent to the CDN. Then a player is a key piece here. So player knows how to play the streaming files or on demand files. It knows all the endpoints for the CDN via manifest file. And ultimately, viewers are able to watch the stream all around the globe. Any questions so far? Okay. And this is a basic introduction to media file, right? So in media, there is a called container format, which is the outer layer. The file itself is hosted inside it with the header information as well as the payload, which the payload contains the encoded media data, so video, audio, and other visuals. An example of the container is MP4, which is you most probably familiar with. Like anytime you record a video on cell phone or your home camera, ultimate goal is to have the MP4 file so you can play it on your desktop, phone, or other devices. So this is an example that MP4 container contains a header information and the H.264 AVC codec video track and the AAC codec audio track. And it can also contain multiple audio tracks for different languages as well. Okay, so we talked about container MP4, which is a highly compressed container. So just wanted to spend some time why we need to compress the video. In this comparison, a single frame of video, the HD frame with 24 bits and 8 bits color depth is 5.93 MB per frame. So if you have this HD video with these specs for about 1 second, it's gonna cost you 177 megabytes per second. And then if the total size of the video is 2 hours, let's say it's a movie, 2-hour movie, the space that it requires for storage is 1.22 terabytes. Now you can imagine that the high resolution uncompressed video can take a lot of space and processing. Also, it's not efficient to stream this to the lower end internet connection devices. And that's where the video compression comes into the picture. So in general, codec term is for coding and encoding of a source file. So it's a software. Encoders and decoders could be software or hardware based. It compresses the data to reduce the transmission bandwidth and storage. And there are two types of classification within compression, right? So lossless compression and lossy compression. So anytime you apply compression, it of course degrade the quality because the original source has lots of information in it. And when we apply compression, depending on individual algorithm, it reduces some redundant part or reduces some details out of it. So in this one, I'll highlight two video codecs which are frequently used is H.264 AVC codec. Azure Media Services supports that, as well as the H.265, which is a newer version of high efficiency video codec, HEVC, which is the newer standard, and most industries are trying to catch up to HEVC. There are third-party programs and tools or encoders or codecs that can do the HEVC encoding. On the audio side, the FLAC and ALAC is the lossless compression. So just a side note, I was setting up the media center in my home with like 7.1 Dolby Atmos. And then I wanted to leverage the true potential of the media system. So I downloaded certain FLAC files, lossless audio, and compared it with MP3 playback, and it was amazing at a different level. So lossless compression files have a lot of details in audio. Okay. All right, so that's up done with the slides. I'm planning to demo the media services in Azure portal. What we will do is we'll create the assets. We'll upload the sample video I have, and then we'll show the encoding process to multiple bitrate, which is called the bitrate ladder. If you have noticed any video player, most probably the YouTube, there is an option for you to select the resolution. The bitrates are also associated with the resolution. So HD resolution with 5 Mbps bitrate and so forth, which determines the quality of the video. So media services has a capability to output multiple bitrate files so that depending on customer internet connection, the server can switch back and forth to different qualities based on their connection speed. And we'll go through the publish process for the video. And then finally, we'll stream video or play it in the player. Okay, any question? All right. So we'll go ahead and create a resource group real quick. And then you can go in and create resources. So select media services and go ahead and create. Okay, so what all you need is the account name, subscription, resource group, existing, METV2. The location is the West US. And as I said, for media services, the foundational block is the Azure storage account. So we'll go ahead and create new storage account. We'll just do the general purpose V2 standard performance LRS OK. All right, and go ahead and create. So this takes probably a couple minutes or more. So I have another instance already created. Once you kick off the media services, it creates following resources in resource groups. So let's understand one of it. The first one is the storage account. Essentially all the media or the assets that Azure Media Services works with, it has a connection to the storage account. This could be the existing storage account or the new one. There is a media services service. This provides general overview of the REST API endpoint. So by the way, media services you can interact with using Portal as well as the REST APIs, and there are different programming model as well for .NET and I believe Node.js. But essentially what I would see here in a media service is that the streaming endpoint is running. This is it, initially it will be stopped, but then you can click on it and then start the endpoint. The another thing it creates is a CDN. So it creates the CDN endpoint, which is essentially your CDN URL. So any videos that media services encodes, it automatically syncs with this CDN service and the CDN profile. So currently, or by default, I would say it is using standard Verizon CDN profile, and there is a custom name associated with the CDN profile. Okay, so with that, I'll go into the media service and then go to the assets. So this is the starting point for media services. Let me switch back to the other resource group, which is been created now. So I can start fresh. Okay. By default, it stops. So I'm going to start it. And then when you start it, it creates the CDN endpoint and a couple other things, the profile and the endpoint. Okay. While this is starting, I can go to the assets. This is the starting point for the workflow to kick off. In my case, I'm going to upload the video, which I already have on the disk. So we'll go ahead and select this Azure Machine Learning clip that I have. Okay. And as you notice that I'm uploading MP4 file. This is not the real case. In real world, uh, organization will be uploading the uncompressed raw video file. Every camera, like HD cams and all the movie cameras, have their own specific formats. Apple has most common format is the ProRes 4K or the ProRes HD. So generally, organization uploads the uncompressed source file and then ask media services to encode it to the different resolutions. But in my case, I'm just putting MP4 file, which means I don't need to go through the encoding process because this is already encoded, but I'll still go through that. In a normal workflow, this is all the file upload is all automated, which means that there are RESTful APIs, which the solution would look something like this as the uncompressed media is dropped into the storage account, and then using triggers or the Azure functions, it can create a job for it to for media services to start the encoding process. So in real world, the entire workflow would be automated. Okay, so once the file is uploaded, I would go ahead and click on that file. And this is the view that I have where I can do various things. In this case, I'll start with the encoding process now. So I have uploaded a file to the storage account and now moving forward to encode it before I can publish it and consume it. Right. So encode is the second step. In encoding, there are various codecs supported. As I said, there are two encoders, media encoder standard and media encoder premium. The charges are varies significantly between these two encoders, as well as the capabilities are much more advanced in a premium encoder than the standard. So the second thing I have to make a choice is the encoding preset. What this provides is all the supported encoding preset that Azure Media Services supports. The most common one is the content adaptive multiple bitrate MP4 files or the adaptive streaming. And if the organization has a specific requirement on H264, then they can certainly select or encode their files based on these profiles. So in my case, I'm going to go ahead and select the content adaptive multiple bitrate MP4 files, which means that it should create from single MP4 file, it should create different 3 or 4 bitrate separated files for lower resolution up to the highest resolution. And then media encoder has a concept of job. So this will create a job and then output the file. So we'll go ahead and create it. So I can go back to the jobs. Let me just browse through here. So go to the media service and then click on jobs. So this will show the submitted jobs which are currently being processed. So at this point, media services is behind the scene reaching out to the encoder uh, instances and then providing the shared access signature of the file and asking and then based on the preset, it is executing commands on open source software called ffmpeg, which generates the files and into the storage. So you can click on the jobs and you should be able to see the progress here. So it reports back the progress. So generally the file is small enough, shouldn't take more than per minutes. But in interest of time, I can show you what the completed encoded file look like. Okay. So when the encoding completes, it's the multi-bitrate MP4 file is output. And this is the kind of packaging that media encoder does is it has the ISM files as well as the manifest XML files along with all the different resolution video files. As I said, I encoded it for multi-bit, which means that it has a lower resolution from 32180 to all the way 1280 to 720, which is the source. So my source was this highest resolution. And what media encoder did it actually downgraded the files with a different bit rates. And you can see the size is much smaller here than the original 50 meg file. Now, when user plays the file, it actually reach out to the manifest and player is aware that there are multiple segment of files available with bit rates. So depending a player determines what's the user's internet connection speed. And based on that, it asks segments of the various bitrate. For example, if you play the video and start with the lowest resolution, but your internet speed for some reason improves, the player automatically switch back to the next one or the next one, as well as the user also have a choice to switch back from top to bottom. So once this encoding is completed, the next step is to publish it. And now this publish the file to the CDN for consumption purpose. And you have two locator types, is a streaming and progressive. So streaming is mainly for the video streaming services. Progressive is like, if you might have heard, the large file downloaded progressive. So latest browser supports, let's say you have a 500 meg movie and you don't want to wait until all the 500 meg is downloaded before you can start play. Progressive will allow you to start the playback as it downloads the segments from the server. So in my case, I'm going to just go with the streaming protocol. And this has some sort of end date. It's valid for, okay. So once the locator has been added, I would go in and play. So Azure platform provides a quick player here to verify, but essentially you can use any supported player, for example, GW player, or Microsoft has its own Azure Media Player called AMP. So you can use that player, and essentially what you would do is you embed this JavaScript player into your website and provide it the playback URL, and the player will take care of the rest. As you know that it points to the manifest file, it does not point to any MP4 because player will determine based on the speed which file segment to request. And the bitrate option that I have available here are from 180p to all the way 720p.
Malik, we have 2 minutes, man. Just a time
Perfect.
check.
I'm right on time. Any question?
Hey, I got a question.
Sure.
In the storage account, is it stored as a blob? It's got to be.
Yes, it's a blob storage.
Okay. And
Yeah.
is the audio and video stored together?
So the video and audio, the audio and video um, are combined in a container. So you would see one .mp4 file, but if you go further, that MP4 file contains audio track and video track both. But so far, the file structure that you will see just one MP4 file.
Okay, perfect. Thank you.
Sure. Okay. Any other questions? No? All right. So back to you, Navid.
Thank you. Thank you. And Malik, really good presentation. And what we will do is we will upload it to our YouTube channel, and you can watch it later on demand. And I will upload the presentation there as well. And thank you very much, everyone, for joining. Just want to let everybody know there won't be any session next week due to 4th of July. Thanks again, everyone, for joining. Happy Friday, and thanks, Malik, for an excellent presentation. Have a great weekend, everyone.
Thanks, everyone.
Malik, great presentation. Thank you, man.
Thank you.
Thanks.
Thank you.